The topic is steady versus transient heat transfer. Heat transfer problems are often classified as being steady, also called as steady state, or transient, or also called unsteady state. The term steady implies no change with time at any point within the medium, while transient implies variation with the time or time dependence. Therefore, the temperature or heat flux remains unchanged with the time during steady state heat transfer through a medium at any location, although both quantities may vary from one location to another. For example, heat transfer through one walls of a house will be steady when the conditions inside the house and the outdoors remains constant for several hours. But even in this case, the temperatures on the inner and outer surfaces of the wall will be different unless the temperatures inside and outside the house are in the same. The cooling of an apple in a refrigerator, on the other hand, is a transient heat transfer process since the temperature at any fixed point within the apple will change with the time during cooling. During transient heat transfer, the temperature normally varies with the time as well as position. In the special case of variation with the time but not with the position, the temperature of the medium changes uniformly with the time. Such heat transfer systems are called lumped systems. A small metal object such as thermocouple junction or a thin copper wire, for example, can be analyzed as a lumped system during a heating or cooling process. Most heat transfer problems encountered in practice are transient in nature, but they are usually analyzed under some presumed steady conditions since steady processes are easier to analyze and they provide the answers to our questions. For example, heat transfer through the walls and ceiling of a typical house is never steady since the outdoor conditions such as the temperature, the speed and direction of the wind, the location of the sun and so on change constantly. The conditions in a typical house are not so steady either. Therefore, it is almost impossible to perform a heat transfer analysis of a house accurately. In the case of multi-dimensional heat transfer problems are also classified as being one-dimensional, two-dimensional or three-dimensional depending on the relative magnitudes of heat transfer rates in different directions and the level of accuracy desired. In the most general case, heat transfer through a medium is three-dimensional, that is, the temperature varies along all three primary directions within the medium during the heat transfer process. The temperature distribution throughout the medium at a specified time as well as the heat transfer rate at any location in this general case can be described by a set of three coordinates such as the x, y, and z in the rectangular or Cartesian coordinate system or cylindrical coordinate system. The temperature distribution in this case is expressed as T of x, y, z, t or T of r pi z, t. The temperature in a medium in some cases varies mainly in two primary directions and the variation of temperature in the third direction is negligible. A heat transfer problem in that case is said to be two-dimensional. For example, the steady temperature distribution in a long bar of rectangular cross-section can be expressed as T of x, y if the temperature variation in the z direction along the bar is negligible and there is no change with the time. A heat transfer problem is said to be one-dimensional if the temperature in the medium varies in one direction only and thus heat is transferred in one direction and the variation of temperature and thus heat transfer is other direction are negligible or zero. For example, heat transfer through the glass of a window can be considered to be one-dimensional since heat transfer through the glass will occur predominantly in one direction and heat transfer in another direction is negligible. Likewise, heat transfer through a hot water pipe can be considered to be one-dimensional since heat transfer through the pipe occurs predominantly in the radial direction form.